Hey, everybody out there. Welcome to a very special video where we have Guillaume Valadon, our staff cybersecurity researcher, here to talk about some recent findings he's uncovered in his work around Laravel app keys that have leaked that allow for remote code execution. So without any further ado, Guillaume, welcome to this video.
Thank you.
So let's start with the basics. What exactly is a Laravel app key and why is it such a critical piece in the security puzzle for PHP applications?
Yeah. So Laravel is a web application framework used a lot. As of today, it's used by millions of applications on the internet, and it's a framework used to simplify development. So you have authentication out of the box, database management, and the app key is used in Laravel to do several critical things related to security, and one of them is related to sessions and authentication. And one key aspect of Laravel and AppKey is that by default, Laravel will use it to encrypt and decrypt some information without providing any other keys than the AppKey. And within encrypt and decrypt, this function in Laravel, there is something really critical for security, which is called serialization. And by default, Laravel will deserialize when it decrypts data. So which means that if an attacker is able to push some encrypted information to a Laravel application, in the end of the day, Laravel will deserialize.
So Laravel is a very powerful open source PHP framework, very popular these days. It's one of the most popular ways to deploy PHP. Now, the particular vulnerability you investigated hinges on how Laravel handles deserialization. Can you walk us through how exposed app keys can lead to full remote code execution?
Yeah, so by default, the new Laravel deployments are not actually vulnerable to what I will present and what we discover with my Synacktiv colleagues. But the other version, and indeed the most deployed version in internet, they are susceptible to actually do deserialization when decrypting information. And back in the first version of Laravel, some encrypted information were stored in sessions. So basically, you will connect to a website. The website will give you back session data, and the session data will be encrypted with the app key. So when Laravel will receive your session data, first thing you will do is that decrypt data, then deserialize. And if an attacker knows the app key on this specific vulnerable Laravel application, he will be able to encrypt his own payload, and then the payload will be decrypted by Laravel and then deserialized. Most of the time, in PHP vulnerability, what you look for, what attackers are looking for, it's called PHP, gadget chain. It's a bunch of functions that you will call sequentially, and these calls will end up in code execution remotely. And unfortunately, with Laravel, we have the deserialization, which is automatic when you decrypt, and also there's a lot of well-known PHP gadget chains that attackers can exploit to actually do remote execution. That's why it's really, really dangerous.
Wow, that does sound dangerous out there. But you say this isn't affecting current versions of Laravel, right?
It could it could affect current version, but in that case, the developers must change some specific settings. For example, they will need to tell Laravel to explicitly store session information in the cookies. But the whole security community is aware that as soon as an app key is leaked, it's basically the end of your Laravel application, because it's not only used for sessions, it's used internally for many things. So most of the time, if you're able to get the app key and get data to the Laravel application, it means that you get RCE. It's not that trivial. It's not that simple as using the session. But yeah, it's well known around the community that basically the leak app key is the worst that can happen to a Laravel application.
So you mentioned you collaborated with Synacktiv. How large of a role did they play in scaling this research? And can you tell us a little bit more about that partnership, like how it began?
So Synacktiv, that's a French pen testing company based in Paris, not so far from our offices. And I think it was last November, I was attending a conference in France called GREAC, and they presented the first research on the app key and what they did. So basically, they explained what we discussed so far, what is Laravel, what you can do with an app key, and they basically said at some point that they try to collect app keys. And for me, and working at GitGuardian, it was really funny to hear that, because they managed to collect using Google Docs, GitHub Docs, or other form of research to collect like 6,000 app keys. And I was like, okay, come on. I think we have more in our public monitoring, and maybe that's a way to collaborate. That's so at the end of their talk, I went on stage, talk to them, and say, okay, guys, do you want to try to have a look? Do you want to collaborate? Because maybe we can find some more effective ways to find more app keys, and that's how the collaboration started.
Right on. And you were able to extract over 260,000 app keys from public GitHub data. So how did that detection process evolve? What patterns were key to identifying valid exposures?
So yeah, at first we tried to be smart and try to look for a bunch of different patterns, but after some iteration with Synacktiv colleagues, we just end up by looking at what is in the .env file, which is basically app key equal and then the 32 bytes X digits. And because at GitGuardian we have this public GitHub monitoring product that is archiving GitHub commits since 2018, we are able to easily and kind of quickly grab a lot of different app keys. And for them, it meant that they were able also to scale their results. So at first, if I recall correctly, they managed to do 400 remote code execution. And then with our data, it was a bit more, so 600 remote code execution. The simple one with the session and the PHP serialize in the object in the session.
That's really relying on GitGuardian's core strength, doing real-time detection across, well, basically the entire open source ecosystem, looking at everything that comes across GitHub public. We are going to link the blog post that you wrote down in the description below this video. And one striking stat was that over a third of these API keys also exposed other sensitive secrets. So what kind of secrets did you find, and what does that say about the broader developer hygiene?
The focus at first was Laravel and app key. I quickly had a look at the file names leaking the app key, and most of them are related to the .env. So .env production, .env staging, and so on. So my next idea was to scan for all secrets in the .env and check if they are actually valid or not, and also check if they are related to Laravel or web application development. And the funny story is most of these sensitive secrets. So again, most of them are valid, are related to database like MongoDB, cloud environment, AWS, e-commerce, mainly payment like Stripe tokens. And it was kind of striking to see that people, when they leak one secret, indeed they are leaking a lot of them. So in the case of e-commerce application, people are leaking basically their front end, their infrastructure with AWS, and also everything related to payment, which is really, really critical.
That makes sense. If you're leaking one thing, there's probably a good chance you're leaking other things as well, and your hygiene could use some improvement out there. So how did these research insights translate into any product improvements at GitGuardian? Can you tell us anything about the new Laravel app key secret detector?
Yeah, so the first one of the first thing we did after sharing data with Synacktiv was just to try to think if it was possible to actually detect this app key at scale and quickly as we do in the product. Turn out that detecting the 32 bytes is really easy. So we work with colleagues in engineering to implement the pattern. And the next step was to actually ask us if it was possible to do a little bit more. And by digging into the data, we figured out that from time to time, the app key variable is leaking, but also something called app URL. And app URL is just the host name of the website. So it's possible if you get app key and app URL to do more than secret detection. You can do also check the validity of the secret. And that was super effective. And we have that in the product today. We detect app key. And when it's possible, we also detect app URL and do the live scanning and the live detection. And we, since 2018, we managed to find close to 30,000 of app key and app URL leaked at the same time. 10% are still valid today, which is really, really huge. And 120 are still vulnerable to remote code execution. That's, again, really huge. And out of that, 50% were removed from GitHub, which means that we are able to find critical information, app key, app URL that were actually removed from GitHub. So someone kind of noticed that we are leaking some really critical data, but instead of doing revocation, decided to remove from GitHub.
So this is a great example of, we're not doing research for research's sake. We're really bringing it full circle, that the research is really translating into real world protection for pretty much everyone on the internet. So we have our Good Samaritan program, but also for our customers, like helping them really tackle this problem head on. So thank you for your work on this. And we'll end here with any advice you have for developers and DevSecOps teams listening today. What should they do if they discover a leaked app key? What does proper incident response and secret rotation look like in this context?
So in the case of app key, it's like regular key. You need to take an app key as a regular key. Really critical when it comes to remote code execution, but still, if you find a leaked app key, you need to revoke it. You need to replace it, and you should not keep using it. So sometimes it's difficult because you might have some sessions, some data already flying around in a customer's browser, but still you need to be really aware that a leaked app key means remote code execution. And the other important point, which is a bit more difficult, from time to time, you just buy softwares. And these softwares are websites, and you might don't know it when you buy the license, but the software is developed in PHP. And it's a Laravel-based application that you are buying. You need to talk to the developers. You need to make sure that the app keys are actually unique in your deployments. So what the people, the researcher from Synacktiv discovered, that from time to time, you have developers selling the same application to several customers, but the app keys are the same. So if you're able to crack the app key to find a leak app key, it means that you will not only compromise one instance, but all of them, which is really, really bad.
Wow, that does sound dangerous out there, but we know what to look for. And thanks to your work, this should be pretty straightforward to catch if you're, using GitGuardian. So
True.
thank you so much for your time today, and thank you for the research. I think you're helping a lot of people out there stay safe. And as we continue to do more research, you can benefit from that by using GitGuardian. And if you have any questions, feel free to reach out to us. We'll set up a demo with you. We're happy to walk you through what our options are. We'll put a link to that down in the description of this video as well. And again, thank you very much, Guillaume, for all of the work. And thanks everybody out there. Please share, like, and subscribe to share this knowledge out with the rest of the world.
Thank you, Dwayne.